Bonjour, messieurs et mademoiselles. It's Wednesday, the 3rd of March. Here's our maths lesson for today. Just like early this week, we're reading and interpreting line graphs, but we're also going to look in today's assignment at plotting line graphs as well. Okay, so to read, interpret, and plot line graphs. Three things we're going to do in the video. We're going to look at a starter task based on your work on challenge A from the previous assignment, so we're going to look at some questions in a moment. Then we're going to go through the answers to assignments from early this week, so Mondays and Tuesdays tasks, and finally we'll look at today's assignment. Okay, so let's begin with our starter task. What I've got here is challenge A from the previous assignment, which was to come up with your own set of questions for this line graph. Alright, now what I've got are 4 questions written by you guys. So we'll start with question 1 from Charlie Ayton. Which month was 15 degrees centigrade? So in which month was the temperature 15 degrees? Kyle came up with this one. What was the difference in temperature from February to March? Emily had explain what happens to the temperature between August and December. How is this shown on the graph? And Charlie C, find the average temperature across the whole year. So that is your starter task. Remember, challenge A from the previous assignment, and here are the questions. So you're going to want to pause the video now so you've got the questions on the screen. So question 1 then from Charlie, which month was the temperature 15 degrees centigrade? Well, you have to hopefully have annotated your graph along from 15 degrees, and you would have found that the answer is April. We've got January, February, March, April, which is 15 degrees. So the first answer was April. Kyle's question, what was the difference in temperature from February to March? Well, let's look at the temperature in February. We can work across from February. It was 4 degrees, and March was 9 degrees. So 4 and 9, what's the difference? Difference is a subtraction, so 9 take away 4. The difference is 5 degrees centigrade. Remember, you must use your units. 5 degrees. Question 3, explain what happens to the temperature between August and December. Well, you can look at the values on the graph. You can see here that August, go up to August, the temperature is 27 degrees centigrade. December, however, the temperature is 10 degrees centigrade. So we've gone from 27 to 10, therefore the temperature has decreased. And we can show that on the graph because of the way that the line is descending. The line is going down. So therefore the temperature drops, decreases between August and December, which I'm sure we can tell by our common sense anyway. It does tend to get a bit colder in winter, doesn't it? And the final question, find the average temperature across the whole year. You should be able to remember how to work this out. What you will need to do is add up, find the total of all of those temperatures for each month, and there are 12 months, so when you have found the total, you will divide by 12. See if you can work out that now if you haven't done already. Okay, so you may have found it easier to change the values here into a table like we did on one of the previous lessons where you were filling in the table based on the line graph. So what I've done here is listed all of the monthly temperatures going down in order. I found the total. The total was 176. And because there were 12 months, I've done 176 divided by 12, which got an answer of 14.6666, so 14.6 recurring, which we can round to 14.7 if we're doing it into 1 decimal place. Equally, we could round it to 15 degrees centigrade. You don't have to round degrees to the nearest degree because you can have a decimal value. It's not like when we had the mean number of pets and you couldn't have a decimal value of a pet, but you can leave it as 14.7 degrees or even 14.6 recurring when it comes to that answer. So well done if you work those out correctly. So that's the starter task done. Let's have a look at the answers to the tasks from the previous assignments now. So here's the sheet from Mondays. lesson, we've got reading interpret line graphs. We were looking at this line graph in particular here. Now for question 1, which day had the highest amount of screen time? Well, let's look at the value that's highest on the y-axis. Look along the lines here, and it is Friday. So the day with the highest amount of screen time is Friday. Which day was screen time double Wednesday's amount? Well, like we've said in the other videos, if you get a ruler, and let's look at where Wednesday. Okay, so we can draw our line up here. Wednesday is at level with 200 minutes of screen time. So if the question says double Wednesday's amount, well, we're looking for double 200. Double 200 is 400, so we can line up 400. Which day does that go to? That is Thursday. Okay, so the answer for question 2 is Thursday. Number 3, how many hours of screen time were recorded on Monday? It's important. I saw people putting 300. I saw people putting 3. However, this is minutes. And how many minutes are there in an hour? There are 60 minutes in 1 hour. So if you've got 300 minutes, we need to do 300 divided by 60. How many times is 60 going to 300? 5 times. The answer is 5 hours. What was the total screen time across the week? Well, we've got to add up the screen time. We've got 300. We've got Tuesday is 450. We know that Wednesday was 200. We worked that previously. We know that Thursday was 400. And when we draw a line along from Fridays, we can see that it is 650. How do we know it's 650? Well, each interval, each square is 100, and we go half a square, so that's 50, 650. Now we need to get the total. That'll be 0 in the ones column. We've got 2 5s, which make 10. Carry that over. So we add 4 is 7. Add 2 is 9. Add 4 is 13. Add 6 is 19. Add 1 is 20. 2,000 minutes of screen time across the week. Now, if you remember our work from last week, what was the mean screen time? Well, we've got to divide 2,000 by the number of values that we input, which was 5 days. So the mean screen time, 2,000 divided by 5, which is 400. Can you spot something we should have added? In both of these, we need to add the units. It's 2,000 minutes. Really important to remember that in data questions, to remember to add the units. And we've got Tuesday's task here. Don't worry about the challenges, we're going to come on to those shortly. And this graph shows the distance the bus travelled over 1 hour. How far did the bus travel in the first 10 minutes? Well, we've got here 10 minutes on the time. And if you see where that line joins up, it is just above 10. It's 1 square above 10. Now again, we have to work out what each square is worth. Well, if 5 squares equal 10, then 1 square must equal 2. Therefore, the answer is 12. 12 what? 12 kilometres. Because that is the value on the y-axis, kilometres. In the first 30 minutes, again, we can annotate, label, draw all over the line graph if we need to. And we can see here is 2 squares below 40, so that's 4 below 40, which is 36. 36 kilometres. And in 1 hour, again, 60 minutes, 1 hour, draw our line, draw it across to the y-axis, and that is 72 kilometres. The speed of the bus increased, decreased, or remained unchanged? Well, that line is a steady, straight line. It's not changing in gradient. It is a straight line. And you can see here, that every 10 minutes the bus is travelling 12 kilometres. So 10 minutes, 12 kilometres, 30 minutes, 36 kilometres, that's 3 lots of 12. 60 minutes, 6 lots of 12. So speed remained unchanged. Question 2. The second part of that worksheet, this graph shows the distance Sam ran during 3 hours. Find the distance Sam ran in the first hour. Again, we can use our ruler, draw our line. That is 8 kilometres. What about over 3 hours? Well, again, let's use our ruler, draw the line, and across. Use a steady hand if you're not going to use your ruler, but then again, you're probably not doing it one-handed. That is, in 3 hours, he's travelled 16 kilometres. Find the distance Sam ran before he stopped for a rest. Well, how do we know he stopped for a rest? Well, that's here when the line changed. Okay, when the line becomes horizontal, that means that the time is still increasing, but the distance hasn't increased. So if time is passing, but he's not going any further, that must mean he has stopped. And he stopped for 2 squares worth here. If you remember from the previous video, we can work that out. You can see here, 2 squares, each square is worth 15 minutes. So 2 squares must be 30 minutes. 30 minutes rest. And how far did he run? Well, that equates to 12 kilometres. He's not done too badly, has he? Getting 12 kilometres before he needs a bit of a rest. Did he run faster or slower after the rest? Well, in the first 1 hour 30 minutes, he ran 12 kilometres. In the second, sorry, in this hour here, he ran 4 kilometres. So we can see that in the first hour, he ran 8 kilometres. In that final hour, he ran 4 kilometres. Therefore, he ran slower after the rest. Those answers again there. Okay, challenge B then. Bit of a tricky one, this one. Describe what occurs between 4 and 6 minutes and between 8 and 10 minutes. Well, as we mentioned on one of the previous tasks, or previous part of the video, the line goes horizontal at 2 points, so here and here. The time continues, remember it's continuous data, so the time is still continuing, but the distance doesn't change. So what has happened? Well, he has, or she, or whoever this is, has remained stationary. They have stopped. So they've not travelled any further between those times. So that is where the person has stopped moving. Part B then, estimate how far the distance travelled will be after 1 hour. Okay, so a few different suggestions for this one. Now, the most common was 36 kilometres. Good estimate, but can we justify it? Well, I'm going to use a few people I know. Grace did this in class. I know Carl's made a really good explanation as well on Teams. We worked out that on the graph we can see that 14 minutes is 8 kilometres. So after 14 minutes, 8 kilometres have been travelled. Well, how many times does 14 minutes go into an hour? 4 times. So every 14 minutes is 8 kilometres. So after 28 minutes, that's 16 kilometres. After 42 minutes, that's 24 kilometres. And after 56 minutes, that's 32 kilometres. And that's almost the hour, but not quite. We need 4 minutes more. Well, we could go back to the graph, as Carl did, and say, right, well, after 4 minutes, that was 2 kilometres travelled. So if I need 4 minutes extra, I can add on the extra 2 kilometres, which will get me a total of, you guessed it, 34 kilometres. Some people came with the answer of 36 because if you notice from the graph here, the line is not always at the same gradient, so it does travel at different speeds at different points. And if we were to say divide 14 minutes by 3, which would be between 4 and 5 minutes, that would be slightly more than 2 kilometres, wouldn't it? But the answer, a really good estimate, would be around 34 or 35 kilometres. Well done if you got a similar answer. Okay, so now we've gone through the first two parts of the video, the start task and the answers to the assignments from previous lessons. Let's have a quick chat about today's assignment. You are going to be, remember, reading, interpreting and plotting line graphs. Okay, so attached is the resources that you need, including the squared paper or the blank paper for your line graph. Just as we've worked previously by going from the line graph to a table, what you are doing is doing it the other way around. You will have a table of results such as this, and you will be plotting those points on a line graph. So the principle remains the same. All right? Use the resources attached to the assignment to help you. Okay, as always, work on Teams or send via email to the Year 6 email address. Please contact us if you've got any questions, and we'll go through some of those answers from today's assignment in the final video lesson of the week. Bye for now.